Welcome back to Understanding VXLAN using BGP EVPN. This is going to be video 5. In this video, we're going to start configuring the VTEP 1, as you can see on the screen. I went ahead and I reloaded it after I did a write erase, so we're starting fresh with this guy. Because this is a 9K, there may be some things. I ran into some issues with GNS3 and the 9Ks where it didn't have some resources. So if it comes to that, if something doesn't work, then I'll have to reload the router. I say router, but this is a layer 3 switch, so it's basically the same thing. Alright, so I'm going to go ahead and start configuring, and then after I configure a few commands, we'll go over them. Okay, so the first command is going to be the NV overlay EVPN. Now that the spines are ready to act as the air traffic controllers, we need to turn on the actual VXLAN EVPN engines on the leaf switches. In this configuration, the first thing that we'll see is the NV overlay EVPN. In the 9Ks or the Cisco NX-OS, many advanced features are turned off by default to save memory and CPU power. Okay, the NV overlay. This stands for Network Virtualization Overlay. It tells the switch, prepare your hardware to wrap layer 2 frames inside the layer 3 packet. Then the EVPN. This specifically tells the switch that we will be using BGP EVPN as a method for sharing MAC and IP address information. Why do we need it? Well, without this command, the switch is just a standard dumb switch or router. If you don't type this first, the switch won't even let you type the other VXLAN commands. Some VXLAN commands might be VNI or interface NVE1. It's just like trying to run an app on a phone that hasn't had the operating system update to support that app. Now, it doesn't matter what order you put the features in here as long as they're in here, right? So let's go over the feature NV overlay. This command is a master on switch for network virtualization. In the NX-OS, you can't just start typing VXLAN commands. The switch will literally tell you that the command doesn't exist. The feature NV overlay tells the switch's operating system, I need you to load the specific software module and prepare the hardware, the ASIC, to handle encapsulation and decapsulation. Without this command, the switch is just a standard layer 2, layer 3 box. It doesn't have the instructions or the muscle to build the overlay. Again, this is going to allow you to type certain commands like interface NVE1 or member VNI. This command enables the VTEP identity. This is what officially makes a switch a VTEP. Remember, VTEP stands for VXLAN Tunnel Endpoint. Alright, now let's explain feature VN segment VLAN based. This one right here. So now that we've used the feature NV overlay to turn on the VXLAN engine, the switch needs to know how to connect the local world to the virtual world. In a VXLAN fabric, we use VNIs, which are virtual network identifiers, and they're used to carry traffic across the network. Now, the Ubuntu desktops, they don't know what a VNI is. They only know about VLANs. Now, this feature allows the switch to glue a local VLAN like VLAN 10 to a global VNI like 10010. Without this command, the switch has no bridge between the underlay and the overlay. So again, if you don't turn this on, you cannot go into your VLAN configuration and type VN-segment 10010. The switch won't understand what you're trying to do. And you'll see when we start configuring this that we can go into VLAN 10, and then under VLAN 10 we can type in that command VN-segment 10010 if it's under VLAN 10. I think these other commands are self-explanatory, again, because this is a 9K. They will not be running unless you tell them to run. So feature OSPF for the underlay, feature BGP for the overlay and EVPN, right? And then feature interface VLAN. So we're going to create several interface VLANs, and you will not be able to create them unlike other switches or layer 3 switches unless you type in the feature interface VLAN command here. I'm going to now go ahead and apply the next set of commands. This right here can be anything you want it to be, as long as it's in hex format. Alright, so kind of what we were talking about before. Let me see if I can make this a little neater. Okay. So here we have VLAN 10, and we're associating this VNI to VLAN 10. It's going to be 10010, and so forth with VLAN 20 and VLAN 30. Again, this is the execution step. After you turned on this feature, these two lines actually build the bridge between your underlay, the local VLAN, and the overlay, the global VNI. So quick recap, VLAN 10, right? This is just your standard everyday layer 2 broadcast domain. On VTEP 1, your Ubuntu desktop, which is this one right here, 10.10.0.50, is sitting in this VLAN. Without anything else, it can only talk to other devices plugged into that same switch on that same VLAN. And under VLAN 10, VN-segment and the number, so this is the link, right? It takes the local VLAN 10 and maps it to the global VXLAN segment 10010. So now VLAN 10 belongs to this VNI, VXLAN VNI. This allows the switch to translate between the 12-bit VLAN ID, which only goes up to 4096, and the 24-bit VXLAN VNI ID, which goes up to 16 million. So let's say when VTEP 2 receives a packet from this Ubuntu, the 10.10.0.50, it doesn't care that you called it VLAN 10. It only looks at the VNI. If VTEP 2 sees VNI 10010, it knows exactly which local VLAN to drop that packet into on its side. Now I will say again that it doesn't matter what which VLAN these guys are on, as long as they're on the right VNI. So if this guy wants to talk to this guy, This guy can be VLAN 80 as long as the VNI is associated to 10010. Alright, that's going to be it for this video. In the next one, we will continue with this command here and the rest of the commands for VTEP 1. I will see you in the next video.